Let's talk about the interior of the Earth right now. There are four layers that we're going to talk about. They're the crust, the mantle, which is broken up into the upper and the lower mantle, the outer core, and the inner core. The crust is the outermost layer of the Earth. It is also the thinnest layer. Its thickness varies from 5 kilometers to 60 kilometers. The crust and the upper portion of the mantle just below the crust make up what is called the lithosphere. The lithosphere itself is made up into many plates, and it sits on top the layer below it, which is the asthenosphere. The crust is made primarily of silicon and aluminum, more so than the mantle, and it has less magnesium and iron than the mantle. So again, to review, the crust is very thin, outermost layer. The crust and the upper portion of the mantle is made up of makes the lithosphere, which sits on top of the asthenosphere, which we'll talk about in a minute. Next is the mantle. This is the largest area of the interior of the Earth. The upper mantle makes up what is called the asthenosphere. It's made up of very weak rock so that it can move. It is the convection current of the heat that's created by the heat inside of the Earth that causes this asthenosphere to move, thus making the lithosphere move. The mantle itself is much more dense than the crust, has lower level is more rigid rock than the upper level, and has very high levels of magnesium and iron content in it. The next layer is the core. The core, though, is not the largest area. It makes up 1/3 of the Earth's mass. The outer core is liquid and made up of iron and is very dense. It can get up to temperatures of about 4,000 degrees Celsius. The circulation of the outer core causes the Earth's magnetic field, so that hot molten rock and how it circulates causes our Earth's magnetic field because of what it's made of. The inner core is solid and it's made up of nickel and iron, and it's also very, very hot and can get up to about 5,000 degrees in temperature. The difference is it's under so much extreme pressure from being in the center of the Earth that the pressure causes it not to become molten like the outer core. How do we determine what is inside the Earth? Well, we do that by measuring the speeds of the seismic waves. As seismic waves are released, they can change speed as they go through different materials in the Earth. So by looking at those different speeds and how they react going through different portions of the Earth, we're able to determine what layers are in there. Now, if we look at this slide at the very end, there are two types of seismic waves, and you're going to learn a lot more about this when you listen to your Khan Academy about this. But these are what we call body waves. You have surface waves that are more like waves that are on the top of the water, those type of waves. But these are body waves that we're talking about, waves that actually move the solid materials and the liquid materials and the gas materials of the Earth in different ways. There are P waves and there are S waves. P waves are fastest and they will always arrive first. And they can travel through air, solids, and liquids. S waves are slower and they only can travel through solids. So if you look at this diagram here, you have your P waves up at the top, and the P waves are going faster. As you notice, the speed along the left-hand side, they are up higher, and they travel through the crust and the mantle, which we know is a solid. They travel much slower through the liquid of the outer core, and then they speed up again through the dense solid of the inner core. If you look at the S waves, though they're much slower than the P waves, they do travel fairly quickly in the solids of the crust and the mantle. Please note that they don't appear to travel at all through the outer core, but they show up again in the inner core, which is solid. So that kind of wraps up what the interior of the Earth is. We're going to supplement this with a couple of Khan Academy videos and another podcast later.